My husband and I, we love houseplants. And one of the remarkable things plants do is to convert light into more of themselves. We call this beautiful biochemical process photosynthesis. As a physicist, what I'm interested in is the very first reaction that light has with a molecule. And to give you an idea of how fast that very first reaction is, I would like to do an analogy. Every day, I spend about a minute or two looking at my plants and seeing how far they've grown. If we compare that minute or two to the entire age of the universe, the entire time elapsed, think about what a small percentage of time that is. That same ratio is the ratio of a minute compared to the ultra-fast timescales that I study. For my dissertation research, I studied the interaction of light with molecules at these ultra-fast timescales. And you might ask, how do you study molecules at such short timescales? And the answer is we use lasers. A first laser light imitates the reaction of the molecule with light. And then afterwards, we wait a certain period of time. And the second laser light takes a picture of the molecule. By changing the amount of time between the first and the second laser light, we can make a frame-by-frame movie of what the molecule has done in that given period of time. For example, upon interacting with light, a molecule might start vibrating, or in a more extreme case, it might break apart in two. For our research, what we were interested in was a special kind of interaction between two electrons. I call it like a dance of electrons, if you want. And this interaction, people have thought to be much more fragile and happen very quickly, much quicker than the timescales that I was talking about earlier. What we found out in our research is that this process was actually more common and was much more robust than was previously thought. So much so that this dance of electrons withstood a violent breakup of a molecule. In the beginning of my talk, I mentioned photosynthesis as an example of an ultra-fast reaction. But these reactions are abundant in nature. For example, right now, as you're seeing me, there's an ultra-fast reaction in your eye that happens that lets you see me. When you go sunbathe during summer, there's an ultra-fast reaction that happens that protects your DNA from the harmful rays of sun. By understanding ultra-fast reactions and the physical laws that govern these reactions, we can help to change these reactions or modify them or even completely prevent them from happening. I contribute to the physical laws that govern ultra-fast reactions and the knowledge that we have about these interactions, because tomorrow's technology can only begin with today's knowledge.